All right, hey guys. So this is going to be the video for Goal 1 notes. These were done in class on August 12th, August 12th and August 13th. So if you missed either of these days for any reason, this is a video you should be watching to help catch up on those notes. So we're actually going to skip over the do now. You are more than welcome to pause this video or fill these in yourself. They're kind of fun. In case you're wondering, the first answer is 6. The second answer is 30 because I did 2 plus 4 is 6. 6 times 5 is 30. So you're more than welcome to do that. But we're going to skip right into the notes portion just because I only have 15 minutes because of this dot camera I'm using to record, and also because it's not a super important part of the lesson. It was just kind of a warm-up. So the first thing you need to know is the definition of relation. A relation is a set of ordered pairs. So what the heck is an ordered pair? An ordered pair is just a fancy name for a point. So that can be any point. We always do our points as x comma y. So it's a set of ordered pairs, or in other words, a set of points that can be represented in many ways. And that sounds super broad, and that's actually because it is. So if we're thinking about a little xy axis, I'm going to draw in, I have my x and my y. This is a point, right? It has an x value and a y value. This is a point, this is a point, this is a point, this is a point. That's an example of a relation because it's a set of points that is represented in one particular way. If we're thinking instead about a function is a type of relation. So it's a little bit more specific than relation, but it's a type of relation where every one input goes to exactly one output. Now I'm going to circle that word exactly because it's where every one input goes to exactly one output. In order to know what this means, I need to know what input and output are. So inputs are x values, outputs are y values. It gets a little bit more complicated than that, but basically at its core, that's what we have. Inputs are x values, outputs are y values. So that means that for every x, I have exactly, so for every one x, I have exactly one y. So one x goes to one y. That's going to make a little bit more sense in a second when we look into these notes. So in class, we did a gallery walk, as you can see at the top. So you would have gone through, found a definition with your group, and then we would have come back together and talked about it. I'm going to just talk about it as on these notes. So if we are talking about a table, a good rule is if a table is a function if my x values do not repeat. If my x values do not repeat. So what does that mean? I'm going to give you an example of what a function is. And I'm also going to give you an example of not a function. A function, not a function. So a table is something that looks like this. This is how I organize my data. So if it was like 1, 2, 3, 5, something like that, and all of my y values were something different, like 2, 3, 4, 5, something like that. If I'm looking at my x values and I see that they do not repeat, I know this is a function because my x values don't repeat. My x values don't repeat. Also, let's do another example. This would not be a function if it went like 1, 3, 4, and then at the end I had a sneaky little 3. This would be 4, 5, 6, 7. It can be anything really. I see that these two x values do repeat. So they do repeat. That means it's not a function. They do repeat. That means it's not a function. I'm going to give you a tricky example now. So if I had a table that looks like this, x and y, and I had 1, 2, 3, and all of my y values are 3s, is that a function? And let's think about it. I almost waited for you to answer, but this is a video, so that doesn't work like that. My rule is that my x values do not repeat. Again, x values are important, so I'm going to look at my x values. It goes 1, 2, 3. Do those repeat? I don't see any x values that repeat. So this one is a function because my x values don't repeat. My y values do, but I don't really care. It is a function because my x values do not repeat. Exactly what I wrote at the top. So that's how I can tell with the table. The next one is called a mapping. It probably is just a map. I probably messed it up, but a mapping or a map. A map is a function if one x value or an x value, I'm just going to say that actually, an x value goes to only one y value. So a map looks like this. So I would have one oval over here, one over here. I'd have an x and a y. My x's are always going to be on my left. My y's are always going to be on my right. So if I had three numbers, let's go with 4, 6, and 7. And they go over here to 3, 5, and 6. My x values are going to map into my y values. This is a function because my x values go to exactly one y value. My 4 goes to a 3, 6 goes to a 5, 7 goes to a 6. An example of something that would not be a function is something that looks like this. I have an x, I have a y. If I had 4 and 5 and then 6, 7, 8 over here, if my 4 went to the 6 and to the 7 and my 5 just went to the 8, this 4 is going to both the 6 and the 7. So my x value goes to more than one y value because it's going to the 6 and the 7. It's going to 1, 2 y values. So this one is not a function because of this bit right here. This means that it's not a function. Let's do a tricky one. We'll do a challenge problem again. So this is my question. Is a map where I have this. These are my x's. These are my y's. It goes like this, 3, 4, and then let's do 1, 2, and let's do a 5 over here. My 3 is going to go to my 1. My 4 goes to the 2. My 5 also goes to the 2. Is this a function? Well, let's check. My x value is only going to go to one y value. So 3 goes to 1. That's good. That's only 1. 4 goes to 2. That's only one y value, x value to y value. And 5 goes to 2. That's also just one y value for my x. So this is a function because even though these two are going to two places, that's still going to work. So my x value is going to only one place, so it is a function. That's another thing to keep in mind. A little bit later, we're going to talk about something that goes with people and places. So that's another way to think about it. Lastly, last page, but we still got to go through a couple more. I have set. So a set is a function if, again, my x values do not repeat. Do not repeat. And a set is just a fancy name for a list of points. So this one, I'm going to give you an example of one that is a function. It is a function. I'm going to use a bracket just because I'm going to have a long list. So I have 3, 5, let's do 2, 7, and 21. I'm going to look at my x values. So I know I'm talking about x values. I'm going to underline those x values. Remember, I write it x comma y. So it's always that one in front. These do not repeat. My x values do not repeat, so it is a function. Let's think about one that's not a function. That would mean that my x values would have to repeat. So let's do one like this. 2, 7, 3, 1, and then let's do 2, 0. Getting a little tight there at the end. I'm going to check my x values. I see that I do repeat. I have 1, 2 over here, 1, 2 over here. So this is not a function because my x values repeat. Good. Just one more example, and then we're going to bring it home with a little conceptual thing. We're going to talk about graphs. I think this is probably one of the trickier ones. So a graph is a function if, I'm going to say this not mathematically, and then we're going to talk about how we prove it mathematically. So a graph is a function if there are no 2 points on top of each other. And we're going to talk about what that looks like. The fancy name for this is the vertical. Vertical means up and down. Line test. And we're going to talk about that right now. So if I were drawing a little axis for myself, this one's going to be my X, this will be my Y. And I drew something that looked like, let's see, if I drew a graph that looked like this. It's just a straight line. It's not super confusing. Is this a function? So I'm going to look at my graph. I don't see any points that are on top of each other. Something to think about is, how do I tell if something's on top of each other? I can draw a line straight up and down. I see it only crosses here one time. I see it only crosses here one time. So there's only one Y value on every one of those lines. So it passes the vertical line test. This is a function. Another way to say that, it's because my vertical line touches only one time. Let's do an example that's not a function. So this one is a function. Let's do an example that's not a function. I'm going to draw my axis again. I have my X, I have my Y, X and Y. And then let's draw something like this. This is called a hyperbola. You do not need to know this, but it will come back for you in Algebra 2. So I have my X and my Y. Well, let me draw in my vertical line. I see it touches here and it touches here. That's touching 2 times. I see it touches here and it touches here. That touches 2 times. That means that these are on top of each other. So I have 2 points on top of each other. That means that it fails the vertical line test, and it is not a function. I'll move it up. It fails the vertical line test. It is not a function. One last thing I want to go over with you guys. You can work on the last page of the notes by yourself if you would like. Otherwise, we are going to do this right here. We are going to map people to places. So people onto places. And that's one way that I like to remember how a mapping works. So if you're having a hard time remembering, if we flip back, that this is not okay. This means not a function. But if it's going to from 2 x's to the same y, that it is a function, which is really confusing, I think. We're going to talk about how that makes sense. So I'm going to make 2 ovals. This is going to be my x. This is going to be my y. We also know that means it's going to be my inputs over here and my outputs over here. I'm going to make that right now. So let's say I'm a person. I'm Miss Keys. So I'm right here. I, unfortunately, at 5:30 p.m. today, am still at school. So me, I'm at school. Can I be in more than one place at once? No, I'm not a time traveler. Sometimes I wish I was, but I can only be in one place at once. I am at school. I think Mr. Baca is still here. So if we're thinking about Mr. Baca as a person, he's also at school. We can both be at school, but Mr. Baca is only at school. He's not at home yet, right? He's only in one spot. So my 2 people can be in the same place, but it does not make sense that a person can be in more than one place at once. And now let's do something crazy. Let's do, who's a good person? I'm trying to think of a celebrity where I know where they are right now. Let's do Dwayne The Rock Johnson. So Dwayne The Rock Johnson is probably in Hollywood. He might not be. I'm very sorry if he's not, but he's in Hollywood. That's where he is. There could be another person in Hollywood. It doesn't really matter, but we know that a person can only be in one place at one time. So hopefully this video was helpful. If you missed, if not, please come to my tutoring on Monday or Tuesday after school, and we can talk about these notes. Reminder that you still need to come take your exit ticket if you miss school, because you can only make up exit tickets during tutoring. Thank you, and I will see you guys in class.